Okay, let's start the chapter. Okay, in this chapter, we will be talking about the IT infrastructure and emerging technology, which is chapter 5. The learning objective of this chapter is what is the IT infrastructure and what are its components? What are the stages and the technology drives of the IT infrastructure evolution, and what are the current trends in the computer hardware platform? Also going to discuss what are the current trends in the software platform and what are the challenges of IT infrastructure and what management solution. I remember in the old days, in the 90s, reason behind establishing such a big company like ITS International Company, turnkey system in Middle East with 28 branches. The first thing started something called Tandem. Tandem is basically a mainframe that compete with IBM mainframe, later on bought by Sun. And each Tandem in that time, like we're talking about over 25 years ago, each one of them is around $2 million startup to reach up to $4 million per piece. And basically, it's self-operating 24 hours, 7 days a week. It's working nonstop. And I was told that during the Iraq invasion of Kuwait, usually these machines, first of all, get sold to a stock market where the chance of down has to be zero. To central banks usually have them, so because they cannot afford to have even zero down system. And it's a complete set of infrastructure hardware, really, plus processing and programming inside all the need of IT infrastructures as a hardware is there. So Tandem, basically during the invasion, when Iraqis came in, they didn't know that much about, big mainframes. So they were, walked in a central bank of Kuwait, and they couldn't do anything. They just destroy everything. So they just took the Tandem, threw it on the floor, and pulled the plugs out. After a year, when the Kuwaitis came back and ITS came back, and they said just we had to do is put it on the top again, and we plug it in and start working. Because Tandem in that time had its own small battery power, which is, it keeps the processing system going on for the application so they don't lose any processing because of the package or cut off the electricities or when you pull them out. Usually, servers and other mainframes, they always need the power, but Tandem had its own powers. It was that much sophisticated in that time. So the IT infrastructure, the shared technology resources that provided the platform for the firm's specific information system application include investment in the hardware, software, and service such as consulting, education, and training. You remember we spoke about a higher education solution, and we said that in order for us to estimate anything as an IT infrastructure, as an IT solution, we needed to start from the top, like from the student teaching, admin, new student alumni. What do these stakeholders need, and how they're supposed to be run? And then we took one step lower for the web base, and we spoke about the apps that they might be, these stakeholders are using. And then according to that, and the infrastructure, the functionality, then the processes that it's needed, we start going down to the data storage infrastructures and then the hardware. So it's really when you are trying to, you know, have an IT infrastructure, an IT solution, you start from the stakeholders to the bottom. But overall, the connection between the firm IT infrastructure and business capabilities, as you notice, this is like we talked about it also on the business strategy. The company, we brought an example of a big ship, and big ship has to coordinate everything together in order to succeed from point A to B. So there is a business strategy plan for a company driven from business strategy, and that influenced the IT strategy for the company, because the IT strategy will help the company to accomplish the goals of the companies. And according to the IT strategy is kind of a IT strategy connected to information technology, and all these three should be helping in developing the IT service and the infrastructure, which is eventually will go to the customer service, supplier service, or the enterprise service, customer service, supplier service, or enterprise service. Now, defining an IT infrastructure, what's an IT infrastructure is made of? It's a set of physical devices and software required to operate enterprise. These set of firm-wide service, including like a computing platform providing computing services, telecommunication services, data management services. We have the application software services, and we have the physical facility management services, plus the IT management, standard, education research, and the development services. You know, we saw some videos in the 70s how IBM was so proud to have a 3GB processor for their big mainframe. So in general, purpose of the evolution of IT infrastructure is a general purpose. It was mainframe and mini computer era, which is in 1959. In the 70s, we just had also these stuff, which is even in up to an 80, in early 90, we used to have something like a floppy disk or a small disk, 3.5 or 4 core or something like that, which is called floppy disks. And when it comes to the personal computers, it started in 1981 to the present, and there where you used to put an operating system desktop, a floppy disk, which has a DOS in it. You put it in and you operate, and then you take it out and you put another one. Before that, they used to have two slots that you put it in order for you to have the PC run, personal computer. Then since 1983, we started talking about and establishing the client, the server, in one PC, which is a stronger, is running all the other PCs processing. And at that time, we had something called AgPack, Simply, which is, we had it in our firm, centralized in the hardware, and every second day, the guy used to come fix it up for us. And it's like, our laptop, our PCs was connected to these just to run these two small application, AgPack and Simply. Now I think it's called now QuickBook and I forgot the name of it. Anyway, so it is an ERP system now. The ACPAC became an ERP system utilized for mid-sized to small-sized companies, has HR and has a financial and income for the taxes and all these things. So there in 1992, we started the enterprise computing era until now. And recently at year 2000, there was something called cloud computing and mobile computing eras. And we brought the example of how we did it for Iraq. We had the whole application running in Kuwait. They will be using these access to this application, and we connected them via satellite, point to point. Early stages of these things. So that was one of a new ways of computing, cloud computing. So overall, if we look at it, the stages of IT infrastructures, and it's if you start from the mainframe and mini computers in 50s, so there was a mainframe connected to computers or mini, dummy screens, probably the best things I can say. And then you have personal computers as we use it today, or called PCs. And then we had a server and computers connected to it. So the processing happening in the server and they get, application from it. Eventually, it started with a computerized or enterprise computing, which is still, some of them use the mainframe, some of them use servers, and some of them a combination of them, and all connected to internet. And eventually what we had, which is called cloud computing and mobile computing, which is, the hardware could be somewhere, the software somewhere, and all connected via the internet. So these are the stages of infrastructure's evolution. What do you usually hear? A multi-tiered client server network, and it's basically when the servers are separated, one for the web server and another for the application, and the third one for database. When you separate, and these are multi-tiers, and usually is the client is connected via internet to the web server, and you do a protocol request, and the request happens through ASCIIs to the application server, take the information, and vice versa. Now, this is from outside. Inside, you could have another, a setup that, application and database directly, or a web server, intranet, to the database. Now, the technology drivers of infrastructure's evolution, there is a few, expressions. One is called Moore's law and microprocessing power, the law of mass digital storage, the Metcalfe's law and network economics, declining communication cost, and the internet, and then you have the standard and the network effect. And each one, we will be talking about each one separately. Now, in the Moore's law and microprocessing power has been interpreted as the power of microprocess usually double every 18 months. And that's pretty quick. The computing powers doubles every 18 months also. And the price of computing falls by a half every 18 months. So that's where it makes it so easy to have, as these processors gets very quicker, the storage get bigger, and more programming comes in the market. And these days they talk about MIPS, or which is million instruction per second. So there is a 128,000 MIPS. So with the business, with the technology of nanotechnology uses individual atoms and more molecules to create a computer chip, which is very small, and other devices. Now, in the Moore's law, basically what he's talking about from the 70s up to 2020, the processing power became 128 now MIPS, which stands for, processing power increased to more than, almost 2.6 billion instructions per second. And the number of transistors, used to be, you remember transistors in the old radios. Now they're pretty small, thin, and number of them like a 2.6 billion transistors into one chip you find there. Now, there is what you call the law of mass digital storage. The amount of digital information is roughly doubling every year. You know, Now getting a 10 terabyte costs you around $200, less than $200, and it might be cheaper now. I used to have 1 terabyte, then became 2 terabyte, and then we found out 2 terabytes is not enough, and then 4, and now 6. And I'm thinking to buy another one as a 10 terabyte backup to these datas that I have. But it's good. The cheaper is the storage, the less worry that you are, categorize them and save them. You can have them, in each folder easily. So that's one of the things that is good. So the cost of the storage is falling at the exponential rate of 100% per year, and this is very impressive. The Metcalfe's laws and network economics is the value of the network grows exponentially as the function of the number of network members. So we don't want to talk that much about it because you know what's happened during the corona. The network it was not able to manage in Canada, was not able to manage this suddenly a jump on, people utilizing Zoom or other tools like, you know, uh, uh, communication collaboration tools. So the network wasn't able to really manage, so they had to work very quickly to manage these because they're getting more important the network setup. But overall, back to the falling cost of the chip, and if you notice here, like in the 65, the price was, very high. And then, the number of transistors, price in US dollars was, 10, and then keeps falling until now is 1/10 of the million 2014, as it's much cheaper now. So the packaging more transistor into a less space has driven down the transistor cost dramatically, as well as the cost of the product in which they are used. On the other hand, the amount of the storage per dollar, it's raising. So if you have $1 in 1950, it costs $1 probably per gigabyte to store it. And now it's like you can have 10 gigabytes and more for the same amount of storage per dollar. The storage is pretty cheap. And now, as you see, small USB can carry 20, 80, 36, 60 GBs, for example. The decline of internet communication costs, although we don't feel that really, but it is true. But the end users doesn't feel it as much as the others do. It is the internet because of the increase of fiber optics and new technology, towers everywhere. So there is the cost of communication is really going down. One reason for the growth in the internet population is the rapid decline in the internet connections and overall communication costs. The cost per kilobyte of internet access has fallen pretty deep. Digital subscriber line, DSL used to call, and cable modem now deliver a kilobyte of communication for a retail price of around 2 cents, something like that. And you know, the speed of internet is pretty quick in some areas, and some of them with the G5 things, required faster internet, more fiber optics. So there really would be there's lots of challenge to come in. Now, there's some important standard of computing which has helped us really to probably move very quickly. First, the American Standard Code for Information Interchange between PCs and servers, an old code called ASCII, which is in 1985. It made it possible for computer machines from a different manufacturing to exchange their data. Later used as a universal language linkage, input and output devices such as a keyboard and mic to computer adopted by the American National Standard Institute in 1963. In the old days, PCs that is made by IBM wasn't similar like the PCs made by other companies, but now they are pretty much the same. Now the COBOL is very old course that you take it in the first year of university, Pascal and COBOL. And it is an easy to use software language that greatly expanded the ability of programming to write business related program and reduce the cost of the softwares. And it's sponsored by the US Defense in 1959. And then you had something called Unix, and then Linux came in its 1969 to 1975. It is a powerful multitasking, multi-user portable operating system. It's usually used for the servers. Mostly Sun use Unix until now, and initially developed by Bell Labs and later released by other users. It depends on the widely use of computers from a different manufacturing. The free version of Unix is Linux, probably adopted, but less. I believe is Unix is a very difficult. It's difficult application. It's not an easy operating. And then adopted by Sun, IBM, HP, and others in the 80s. It becomes the most widely used enterprise level operating system. Then we have the TCP IP, which is the protocol, which is a transmission control protocol, internet protocol. It's like a tag to know who is sending what. And it's a suite of communication protocols and commonly addressed schema that enable millions of computers to connect together in one giant global network, the internet. Later, it was as the default networking protocol suite for the local area network and intranet, and developed by 1970 by the Defense US Department. Have you noticed that lots of the technology comes from the Department of Defense, and it takes 20 years after that the military of USA released that. Like RFIDs was in the started probably 30 years ago, 40 years ago, and then 20 years or 15 years ago, they started releasing this technology to the public. You have, today nobody notifies or understands because it's all done automatically, the TCP IP. and which is called the transmission control protocols over the internet protocol. Then we have this something called Ethernet, and as you're aware, a network standard for connecting desktop computers into a local area network that enable the widespread adoption of a client server computing and local area network, and further stimulate the adoption of personal computers. So when you have a servers and you have or a client, which is a client is a desktop or is connected to the server, that they call it client. There is some kind of a communication tools between them networks, which is part of it is the Ethernet. Eventually, in 1970, IBM built the personal computers, but Microsoft had the DOS, this operating system, built, giving to the IBM and Intel personnel. The standard Intel designed for a personal desktop computing based on the standard Intel process and other standard device. And as we said, Microsoft does, and later on Windows software became Windows software. The emergence of the standard low-cost product laid the foundation for the 25 years of period of explosive growth in computing through the whole organization around the globe. Today, more than 1 billion PC power business of government or government activities every day. And WWW, or the World Wide Web, standard for sorting, retrieving, formatting, and displaying information as a network web of electronic pages, incorporating like a task, graphic, audio, and video, enable creating for the global repositories of billions of web pages. These are today, we think it's a normal thing, but in the old days, it was something special and very interesting. I remember my first email, it was called Rocket Mail. And Rocket Mail, I'm still keeping it. So many times they were asked, Rocket Mail was sold to Yahoo, and Yahoo took it back from me, gave me my name at rm.yahoo.com. So, but the Rocket Mail was one of the first mail, internet mail that was famous in that time. So the IT infrastructures ecosystem made of different pieces that we need to look at them. And we said when the education, we looked at from the top to the bottom. In order to determine the bottom, we needed to look at the top. Here, this pieces is like what's made of overall. Is probably, if we start from, say, let's say from data management and storage, and it's usually types that you heard about the data management and the storage, like IBM DB2, Oracle, SQL, MySQL, Sybase, EMC, Apaches, and Hadoop. And then you have something called the internet platform that you need for, which is Apache, which is made of Microsoft, .NET, Unix, Cisco, and Java. And then you have the computing hardware platform, which is, Dell, IBM again, Sun, HP, Apple, Linux. These are a platform, computer platform, hardware platforms. And then you have what you call the operating systems platform, which is Microsoft Windows, Linux, Unix, Mac OS, Chrome, Android, and iOS. And you have what you call the enterprise softwares application, including the middleware like SAP, SAP, Oracle, Microsoft, different application of IBM, which is all connected through the networking and telecommunication, like a Microsoft Windows Server, Linux, Novell, Cisco, Alcatel, Nortel, AT&T, Verizon, and eventually all these can be working in a very synchronized ways, utilizing if you can use good consultant and system integrators like IBM, HP, Accentures, and there is others too, especially now even Arthur Anderson, Ernest and Young are getting involved in these things also. Now, if we go to talking about the computer hardware platforms, and you know, is the client machine like the desktop you're using, the laptop that we are using, the PDA, the, you know, like a mobile or the tablet. And then you have the server machine, which is a blade server and server farms. Blade servers usually a rack with different small servers. You slide them in. And if you go to the data center, you see there are lots of them. They can operate and connected to Ethernet and you know, some wiring behind. And the more you need, the more one more you put a blade there. And then you have the server farms, and then which is made of servers connected to each other, so full, you know, with its box and everything. And eventually you have what you call the mainframe system used as a giant server for enterprise network and corporate website, like IBM mainframe, like Tandem, the first example I spoke about it. And we have what you call the operating system platform, which is Microsoft Windows dominate the market of the client machine softwares. And then you have what you call Unix and Linux, widely used as a server softwares, which is they are designed in the server side so you can manage them. Linux is open source. Unix is mostly you can find them in Sun. They utilize it a lot. Linux available as an open source softwares. And then you have an operating system platform like a Google's Chrome. You have the Android is an open source operating system for mobile devices, and iOS, Apple's operating system for its mobile devices. And you have these application, which is the provide the process, the work every day, you know, set up the process and bring data and, you know, enter it. And the largest suppliers of enterprise softwares are probably Oracle, SAP, and then Oracle bought PeopleSoft, and PeopleSoft management is major competitive with SIS as an SIS used for lots of university. We spoke about it earlier about you know, student-oriented colleges and university versus research-oriented college. And the student-oriented is try to provide best service, and they utilize usually banners mostly. And then you have the research-oriented, which is their focus on the college itself and its services, because they provide services to organization and government, and that's how they generate their revenue mostly. Then we have what you call database management and storage. Database management, there is an application goes on the top of it, which is called the DBMS, Database Management System, which is database is where you store the data there. And database software, we think, as we talked about the IBM DB2, Oracle, RDBMS, and DBMS, Microsoft, Oracle DBMS, Microsoft SQL, and MySQL. And there is a Sybase who is really declining, which is Adaptive Server Enterprise. And it's a UK base. And then the physical storage, which is you have The EMC is number 11 worldwide in the IT, revenue and business. And it's a large scale system. And they have what you call disaster recovery, backup, and all these things. And then you have that ACPAC is a Sega. They call it Sega now. And then you have Matrix, and you have a Western Digital and Security. And then what you call SANS, and SANS stands for Storage Area Network, which is connect multiple storage devices on a dedicated network. It's just to, try to balance between the networking and the servers. So one server not always running is balancing all these. And usually the EMC has some kind of this application also. Very strong in that application, actually. And then you have the network telecommunication platforms, which is famous of them, Lucent, Nortel, Juniper, Cisco, and Huawei. The software leaders could be, Microsoft, Novell, Linux, and Unix. Now is for the servers, usually we said Linux and Unix, and for the PC client, it's the Microsoft. Novell also is not bad by IBM, but it's not used that much as Microsoft. Then you have what you call the service vendor included, like, Bell Canada, premiums and regional carriers that they can carry, the internet for you, or they can have your storage or infrastructure theirs. And what we have, what you call VoIP or voice over IP, which is the wireless connections that we utilize in such as making phone calls, utilizing Facebook or WhatsApp. That's a voice over IP also. When it comes to the internet platform, we have what you call the hardware, we have the software, we have the management service to support company website, including the web host service, intranet and extranet. And you saw the frame, how it's happened. The beginning of second slide is the client, internet, and then you have the web server, and then you have the application servers and the database back there in the middle. You have the applications, and you have what you call the internet server market. And the internet server market is run by mostly Dell, HP, Compaq, and IBM. They are the servers, not a mainframe, but IBM, part of their mainframe, also they have the internet hardware server. When we talk mainframe, means all these hardwares and networking that's required is within one piece, yet in the servers is separated. You have to separate them. Also the softwares. In the servers, there is a software for the server, server for the internet, but in IBM is one machine, mainframe, IBM mainframe and Tandem. One machine has all these specifications in one piece. And then we have the web development tools, like the front page, the .NET, IBM WebSpheres. You use Java, sometimes you heard of Java, probably independent software development. Others like Adobe is also utilized. And eventually the consulting and system integration services, like ITS called International Turnkey System, and it's focused on system integrating. These are the consulting company, and even large firms do not have resource for a full range of support of a new and complex infrastructures. They keep, new things coming in, so not everybody has these stuff, especially today with the AI and database engineering. Lots of new things coming in the market. There is a software integration which is ensure the new infrastructures work with the legacies. That's another challenge point that whether it's working fine when you upgrade, what will happen to the one of the part of the application. If you have 4 or 5 applications and when you upgrade it, you have to upgrade all these integrating. And then integrating can be native or can be rendering, but rendering is not a real good technology. And then you have what you call a mirroring also. And then you have the legacy systems, which is the older TPS, which is a transaction process system created by the mainframes that would be too costly to replace or redesign. These are the legacy system, and it could be created by old servers also. It doesn't have to be the mainframe. And it's usually people like Accenture, IBM Global Service, Infosys, Wipro on a smaller size, probably ITS, they do these kind of work. But we do have lots of hardwares and it's growing. So there is some kind of a trend, it's happening. There is 8 hardware trends. One is that the mobile digital platform, so you can do your work from anywhere, anytime. And then you have the consumerizations of IT. You consume hardwares or software as much as per what you use. And something called Boyd or bring your own device, like you bring in your PCs or something like that. And then what do you have? The grid computing, we'll talk about grid computing, virtualization, we have what you call a cloud computing, we have the green computing, which is how you destroy the old computer without harmonize the environment. And then we have what you call the high performance and power saving processors. And automatic computing these days is kind of we see a big trends happening where it's called machine learning. And it's basically the machine start computing itself to develop a new result. You heard of the mobile digital platform like a cell phone, smartphone, BlackBerry, iPhone have assumed data transmitting, web serving emails, and IM duties. Smartphone and tablet are increasingly used for business. In the challenge part of it, there is a programming and there is a frame for the programming. So each phone has its own frame. So you might develop a program for mobile, but you need to create separately the frame for each application. So BlackBerry has a different frame that you need to build so the data goes in. The iPhone has a different frame. Nokia has a different frame. And Android now have a different frame. Mobile that's run by Android, basically. So the smartphone, even if your tablet, also has its own different frames, are increasingly used for the business. The consumerization of IT and boy, technology emerged in the consumer market and then spread into business organization. As we said, Boyd, bring your own device. The new challenge for the IT departments, the security part of it, the software availability, the ownership. And we, in the previous slide, we spoke about different framework that you need to build for each of these. You notice sometimes you open a website in your mobile and doesn't fit in your mobile and you need to move it, make it smaller or bigger because they did not have done it they have the programming, but they don't have the web frame, or they are doing purely rendering. So the question, should we use the iPhone for work? And we can discuss these issues on separate, read them, think about them, and let's talk about that. The grid computing. Grid computing is basically, it's a practice leveraging multiple computer, often geographical disputed, but connected by network to accomplish joint tasks. I think there is something that comes in your mind right now. Let me know what it's coming. What do you think? Which one is using now grid computing a lot, and you probably are involved or not? I'm not sure about it. Bitcoin. It also involved connecting geographical remote computer into a single network capable of working in a parallel on the business platform that requires a short-term access to a large computational capacities. It's rather than purchasing a huge mainframe or a supercomputers, you know, firms can chain together thousands of a smaller desktop, a client into a single computing grid. What we have, what you call virtualization, which is a present computing resource so that they can be accessed in a way that are not restricted by configuration. You notice there's some application that you need to do some configuration on your laptop in order to use them. And some application, you don't need to do any configuration, or there is no setup that you need to do. This is what you call virtualization. So it allows a multiple operating system to run on one machine, which has increased the server utilization rather from 10 to 15 to 30% of the capacity, because there is no configuration, so there is no small programming here and there. You have to send it and operate and try to understand who is using what in order to process it from the data base to the application to. It's a whole headache. With the virtualization, you cut all these pieces and make it smooth, connected with each other. And I guess the trend that you hear it is a cloud computing, which is firms offload peak demand for computing powers to remote large-scale processing centers, or they just offload all their hardwares and networking and infrastructures plus software. Firms pay only for computing power they use, as with electrical utilities. Excellent for firms with a spike demand, so they suddenly have a huge demand, especially lots of, so it's easy for, instead of upgrading or adding more servers or making their network, they just have to speak with the provider, SaaS providers, so they can increase it. So excellent for firms with a spike demand curve caused by seasonal variation in consumers like holiday shopping, and saves firm from purchasing excessive levels of infrastructures, which is infrastructures comes in after a while gets outdated, or you have to upgrade it, and maintenance, support, and all these things. This is all get outsourced. But and also the data permanently stored in the remote server, access and update over the internet by user. That might be has the only bad side is the fact that security reason. In the cloud computing, cloud infrastructures as a service, or SaaS, customer use processing, storage, networking resource to run their information system. They pay only for the computing capacities they use. They're using two servers, two CPU, four CPU. That's how they price it. The cloud platform as a service, which is customer use the infrastructure and programming tools to develop their own applications there. And then in the cloud, software as a service you have. Customer use the software hosted on a vendor cloud. So you put your software hosted there, or sometimes they have their own software, you have access to it to run your business. A cloud can be private or public. A public cloud is owned and maintained by service providers, and that private cloud is operated only for that organization. Big organization has a private cloud. Its concern include, as we said, the security, um, the availabilities, and user become dependent on the cloud providers. So right now, most of the big and advanced companies have their servers sitting in Germany. They are from India and they're operating in Canada, for example. But then now there is a rules and regulations that's to work in Canada, especially you need to have your servers or the cloud operating within Canada, for example, in some industries. In the cloud computing, as we said, there is what you call the servers, and then you have desktop users, laptop users, smartphone users, tablet users, all these kind of users. And they do, and the servers are also part of the users. And then they have what you call the inside the cloud, the platform service, which is the storage, the communication network, the identity management, the content servers and content management. And then you have the application services, which could be the content management here. Yes, enterprise softwares. It could be collaboration tools or process management. And then you have what you call the infrastructures, which is the storage, storage management. You have the network management and the computing resource management. Autonomic computing. Industry-wide effort to develop systems that can configure, heal themselves when broken, protected themselves from the outside intruders. Tandem is one of these things. These are usually learning machines are one of these. The trend is coming in. And it's basically all you need is 2 or 3 consultants within the company. They just give a few forms and then the machine will learn how to program and select a report, and then you adjust that report in order to get some kind of a personalized report, something like that. Where it's similar to self-updating antivirus softwares like Apple and Microsoft both use automatic updates. And then you have the contemporary software platform trends, like Unix and open source software, like Moodles and all these things. Then you have Java, HTML, and HTML5. Then you have the web service and service-oriented architectures and software outsourcing and cloud services. The earliest application that use an open source software is Linux, and open source software is a free and can be modified by the users. These days, lots of universities, they utilize Moodle, developed in Australia for education, and it's an open source, and you can, develop it and make it. It's not only for education; it's only for other applications. Also, you can develop it for certain industries. Developed and maintained. It's called Moodle, developed and maintained by a worldwide network of programming and designers under the management of consumers. One of other application that is also it used in telco also. Linux is widely used open source softwares programming. Linux is an operating system derived from Unix. And here I brought an example, for example, Moodle for education, Moodle for transportation, logistics. Then you have what you call Java. Java is object-oriented programming language used by mostly Sun Microsystem, and Microsoft Sun, bought by Oracle. Now they can give you a package of softwares and hardwares together. And for the servers of Sun, you use Java and Unix. You can use also Linux. Operating system processors like a Java virtual machine, leading programming environment for the web. And then you have the HTML, which is hypertext markup language, and the graphic, videos, and sound are placed on the web. And then you have what you call HTML5, which is images, audios, videos can be embedded directly into the document without processes add-ons. Then you have what you call web service and service-oriented architecture, which is a web service software component that exchange information using the web standard and language. And SOA, or service-oriented architecture, is a set of self-contained services that communicate with each other to create a working software's application. Software developers, usually they have a small programming. One of the way of doing, programming, they cut it into small pieces, or they bring small pieces and add it together, and you add more pieces together, develop a new one. So it's like becomes a more sophisticated. It's a software developer reuse this service and other combination to assemble other application as needed. So if we're looking at, for example, how Dollar Rent-A-Car use the web service, is basically they have what you call the legacy system. Their system is a back end here, which is a legacy reservation system. And then they have the servers. And when there's the servers there, these are the system belong to them. So then they have the web services, which have a separated server for it. And then the web service, you can access to it to the Southwest Airline tour operating system, a travel or reservation, wireless, and future business partners. This is very, very close of OG Money. We will talk more about OG Money, hopefully, how this thing is working also. The software outsourcing and cloud service, 3 external source of softwares is in the future, we'll talk about OG Money in details, how their application work, because this is a very interesting, the M service, the mobile value-added service, MVAS, and it's connected the banking system and the telco system in utilizing other application to run it on mobile. So it's pretty interesting, a mix of whatever we are taking now. 3 external source for software, the software package and enterprise software. And we have the software outsourcing that you have your own software and you give it to somebody to use it. It's like the domestic one or offshore one. And then you have what you call the cloud-based service and tools that you can utilize applications. Overall, talking about source of softwares and expenditure in $1 billion. In 2011, we're talking about around $300 billion was spent. When it's come to the software as a service, it's a little bit behind, but it's moving. The outsourced software expenditure is ahead, but now we see moving in software as a service, which is SaaS, and the total spending, as we said, is around $300 billion so far in 2011. And then you have what's something called mashups and apps. Mashups, is a combination of two or more online applications, like what you use, Google Maps, such as combination of mapping software, Google Maps, with the local content like, locally they use these cars capturing local content sometimes for the Google Maps, and they are a local, Google. And then you have what you call apps, which is a small pieces of software that runs on the internet, on your computer or your phone. So small apps, not applications, like iPhone, BlackBerry, and Android. Android is one of the open sources. When you remember when we talked about open sources, Android is one of them. And is generally delivered over the internet. Web stores also considered to be an open sources. Dealing with, which is belong to Google, dealing with the platform, the management issues that dealing with now, we talked to so many factors that you have to take into consideration when you are, this is what you call MIS, not the BIS now. Management issues, dealing with the platform and its infrastructure changes, management and governance, making wise infrastructure investment, competitive forces model for IT infrastructures. That's how you look at it. You look at the total cost of ownership of technologies. Right now, what's your cost? In the future, what's your cost? If you are using these for the next 5 years, what's the hidden cost? You have to find out that you need to discover these stuff. So in the dealing with the platform and infrastructure changes as a firm shrink or grow, the IT needs to be flexible and scalable. You cannot have one of the things that we faced during Corona that lots of companies had is what you call a flexible, but not that flexible. So they had to go through doing upgrading and doing benchmarking to see whether their application can manage that many. And then what you have, the scalabilities, which is the ability to expand to serve a larger number, to serve more people, more users. And you have what you need to deal with is a firm using mobile computing, cloud computing, and there is a new policies, whether how you're going to deal with your data, sensitive data, insensitive data, procedures for managing these new platform, how you're going to manage them, which comes in effect in the contractual agreement with the firms running in the cloud and distributing the software required. The other issue is that you're looking at who controls the IT infrastructure. The IT people usually have a tendency liking to control the IT infrastructures, and the business people like to outsource this headache out. Centralize or decentralize, and how are the costs allocated between the two, between divisions and department when they are centralized or decentralized, when more than one department is using the same application or more location is using the same application, how you divide this costing. And then how you make a wise infrastructure investment, how much to spend on IT complex question. We don't know how much we're supposed to spend. If we don't do our current situation, understand who is, as we said, the stakeholders, and what's the future expansion, types and numbers of the stakeholders. So we have the types and we have the numbers of the stakeholders. In the old days, the third party, the parents, they were not involved in the higher education. So we didn't have that in mind. Now they are involved. Government are involved now in the direct computing, and they want to see how the things is moving. So are we renting, or we are buying or outsourcing? And we said we need to see the total cost of ownership, of technology, of asset, all these things. Now, so the infrastructure component that we really need to look at it is the fact that in the challenging part of it is purchase prices, hardware acquisitions, the purchase prices of computers, hardware, equipment, including computers, terminals, storage, and printers. Then you have what you call the software acquisitions, which is cost of the installing computers and softwares. Then you got what's training, which is you train people on it, cost of providing training for information system specialists and the end users. You have the support part, which is cost of providing ongoing technical support. These are all comes in of total cost of ownership. Help desk, others, maintenance, cost of upgrading the hardware and the softwares, infrastructures, which is cost of acquiring, maintaining, and support related softwares, such as the network specialized equipment, including the storage, backup units, downtime, and cost of, which is cost of productivity if a hardware or software's failure cause the system of unavailable for processing and user tasks, and space and energies, real estate, and utility costs for housing and providing the technology. One of the things came in my mind, I like to tell you a little story. The last king of Saudi Arabia, which is King Abdullah before this guy, he was there when Saddam Hussein invaded Kuwait and almost invaded Saudi Arabia. So the American came in, the British came in, the French, and they supposed to help them. Then after that, they signed a contract with them to protect them. And one day, the one before Condoleezza Rice, as a Secretary of Foreign Affairs, she was at Malik Abdullah requiring, payment or some kind of favors. And this is what came in because there was a hidden cost. They thought there is no cost for protecting these oil weak countries. So he looks at her after she makes the suggestions and all these things. It's not a Condoleezza Rice, it's somebody else. I forgot her name. So he tells her a little story. He said, well, there was a guy, a farmer had a sheep, and there was a fox or a wolf. Every day he eats one sheep from that. So he wanted to protect his goats or sheep. So he brought a dog to protect these sheep. But eventually he had to feed that dog 2 sheep a day in order to protect his sheep, his farm from the wolf who eats one. In a hand, saying that, we brought you to protect us against, for example, Iraq or Iran, and we end up paying you more, and we wish if these guys comes and take their part of their shares and walk away, better. As a little story came in my mind to tell you. So when we are talking about, computing, we have what you call first, you have in the center is your firms and the IT service and infrastructures that you need to develop. And what's drive them? There is an external market factor and there is an internal factor. We start with probably the market demand for your firm customers. What's the customer wants? What's the suppliers wants? And what's the enterprise inside? We said like an enterprise service. Then we need to look at your firm business strategy. So, what's the strategy, how to reach to the goals, and all these things. The third thing is we want to look at, and all influence the firm, is the firm's IT strategy. We said there is, a goals that you need, and there is a business plan strategy built according to the to the strategy, and then IT, business plan driven from that, which is the IT strategy, infrastructure, and cost. And then we need to know about the information technologies, what kind of a trend is using, and all the process, and the competitors firms, what they are using, and how they are progressing or behind us. And then we look at the competitor firms, their IT infrastructures, the investment they are using, and we have to match them or better, stay better ahead of them. So this is the end of the chapter. I'll see you.